In this podcast, we're going to talk about limiting and excess reagents. All right, a limiting reactant or limiting reagent is the first one that is consumed, meaning it is the one that runs out first. Therefore, it limits the amount of products that are made. So you see in this picture, carbon and oxygen form to make carbon dioxide. So you have a bunch of O2 molecules and then this clump of carbon in the middle. When they combine, you see that you have no O2 left, but you do have some carbon left. That means O2 limited how many CO2s you can make. So O2 would be your limiting reactant. All right. In order to calculate limiting reactants, you have to do two stoichiometry problems. You're going to figure out how much product each reactant would make if it were used up completely. And then when the one with the smallest amount is going to be the one that is your limiting reactant. That means that's the total you can make, that smallest amount. All right, here's another picture. We have H2 and N2 making NH3. And here you see that we've got extra N2, which means H2 is going to be our limiting reactant. And in fact, when it combines, we have H2 left, or no H2 left, and N2 left. So that means that H2 limited how many NH3s could be made. All right, on the opposite end, you have the excess reagent. This is the one you don't run out of, the one you have extra of. So if you have cars and tires, and then you have 8 total cars that were combined with tires and 16 extra tires, the 16 extra tires are the excess reactant. The amount of stuff you made is called the yield. All right, so let's just go ahead and dive straight into an example problem. All right, so it wants to know what mass of ammonia can be produced from 500 grams of N2 and 100 grams of H2. So we're going to have to do two stoichiometry problems here. All right, I'm going to go ahead and scroll down a little bit. All right, so we're going to have 500 grams of N2, and this is what we're going to start with. It's our first stoichiometry problem. And we're going to do convert this to grams of ammonia. So both of these amounts we converted to grams of ammonia. They need to be in the same unit in order to compare them. So molar mass of N2 on bottom, 1 mole N2 on top. All right, now mole ratio. We see that this equation is not balanced, so you would need a 3 there and a 2 here for this to be a balanced equation. So we have 1 mole of N2 from balanced equation and 2 moles NH3. All right, now we've got to get this to grams of NH3. All right, so we're going to need the molar mass of NH3, which is 17.0307. Okay, and that gives us 607.9. grams. Okay, so that's using just N2, assuming that the N2 runs out. All right, now we're going to go back and we're going to do the same thing, but we're going to use 100 grams of H2. All right, again, we're going to convert it to grams of ammonia. So we're going to put molar mass of H2 on bottom, 1 mole H2 on top. All right, now we're going to use our mole-mole ratios, which were 3 moles of H2 to 2 moles of NH3. All right, and last, all right, now we're going to multiply everything on top, divide by what's on bottom, and we get 563.2. Alright, so this is the total NH3 that can be produced because that's the smallest amount, which means that what gave us that, the H2, is our limiting reactant. So H2 is your LR. Okay, now it wants to know how much unreacted material remains. Alright, to calculate unreacted material, you want to take the total amount that you've produced, and this is NH3 right here, and we're going to convert it back to the excess reactant, okay, because we want to figure out how much excess reactant do we have left over. Okay, so our excess reactant was N2, so we're going to calculate this back to N2. Okay, so again, we're going to need molar mass on bottom. So this is almost like working backwards. All right, and then you have 2 moles NH3 for every 1 mole of N2. All right, and then we're going to get 2 grams of N2. All right, and we see that we use 463.2 grams NH2. All right, that's how much N2 we used, okay? But we know that we started with 500 grams. So this is what we started with. And then we just calculated what we used. Subtract the 2 and it tells you how much is left over. So let's see. We had 36.8 grams left over. Or unreacted. Okay? All right, let's look at another problem. All right, in this one, we have 2 grams of ammonia and 4 grams of oxygen. Wants to know which is the limiting reactant and how much excess we have left after it stops. Okay, so again, we're going to do 2 stoichiometry problems. We got 2 grams of ammonia. All right, and we're going to convert that to, I chose NO just because water is usually a byproduct, so I chose to go to NO to see how much NO we have. Okay, all right, so we're going to put molar mass of NH3 on bottom. Okay, now we're going to do our mole-mole ratio. So we got 4 moles NH3 to 4 moles NO. Okay. And because it didn't ask us for grams, I'm just going to stop at moles, make my life a little easier. So I'm just going to stop right here and go ahead and equal this out. So let's see, we would produce 0.117 moles of NO if we had 2 grams of NH3 and it was all used. Okay, so now let's go back and do our second part, which is the 4 grams of O2. All right, we're going to do the same thing. We're going to convert it to moles of NO. So we're going to divide by our molar mass. All right, now our mole ratio. 5 moles O2 to 4 moles NO. Okay, and do the math, and it tells us that we have 0.1 moles. So this is the total amount of NO that can be produced. telling us that O2 is your limiting reactant. Okay, O2 is your LR, your limiting reactant. All right, now it wanted us to tell it how much excess reactant remains after we run to completion. So we're going to take our total amount, which was 0.1, and this is NO, and we got to convert it back to the excess, which was NH3, and it's in grams. So we got to go all the way to grams with that one. All right, so we got 4 moles NO for every 4 moles of NH3. All right, now we're going to do our molar mass of NH3. All right, and we got 17.0307 grams. Okay, calculate that out and you get 1.7 grams of NH3. Well, we know we started with 2 grams, so 2 minus the 1.7 that we actually used, and you get 0.3. So 0.3 grams of your NH3 is unreacted. All right, let's look at all right, and I guess that's all the torture I have for you on that. So that's it. That's limiting reactants.